So first of all, Common Core, let's put it back up there. Common Core for today is A for algebra, RE, reasoning with inequalities for I, and it's number 12 out of the list, and it says graph the solution to linear inequalities in two variables and the solution of two half planes. Okay, I'll read it again. Graph the solution to linear inequalities in two variables and the solution of two half planes. So we've been doing that. In fact, we take a look at what we did. Inequalities, we shaded, and we overlapped, and where the two half planes overlapped, that's where we got our solution, okay? Alright, so when you read this problem, have a little sense of humor, alright? I understand that most people probably wouldn't figure out how many plants to put on the roof mathematically. They'd just probably go to Lowe's and buy a bunch of plants. But this girl, Jillian, is smart. She's going to mathematically figure out how many plants to put on a roof. So let's read it. So Jillian is planning a green roof. So that means, on her terrace of her maybe her fancy apartment, because she became an economics professor and she works at Amazon, and maybe she's got a great view of downtown Seattle because she makes plenty of money. She can go up to a rooftop and she can plant some flowers. So Jillian's going to put 600 square feet is her rooftop. She's going to put two types of plants, Blue Lagoon Sedum and the Raspberry Red. So two types of plants, right? Each blue will cover 1.2 square feet, okay? And each red will cover 2 square feet per plant, okay? Per plant, you with me? Each plant costs $2.50. She can spend no more than $1,000, that's all she has, and create a feasible region. So first of all, it's a lot of words, but let's see if we can break it down. I know I've got two things going on. I've got blue plants and I've got red plants, okay? So let's just start right there. Let's let B be our blue plants. B is our blue plants and R for our red plants. Or we could use X and Y, right? It doesn't matter. We could use X and Y, it works also, okay? So let's do blue on our graph here. We'll let our blue be these. We'll let our red be theirs, okay? Now we're going to create some kind of a feasible region. Okay, the very first equation I always like are these two equations. Let's make sure this is greater than or equal to 0. Let's make sure this one is greater than or equal to 0. That's an important one. You can't buy negative plants. It doesn't make sense. You can't buy negative plants. It does not make sense. You have to have positive values. And that's part of the reason when I graph this, you'll notice on my graph that I only graph it in first quadrant. I don't need any answers down here, okay? So when I graph it, I mean quadrant 1, okay? Second thing, let's take a look at a second equation. So we need an equation. There might be a square area, so let's look at an area equation. So I've got 1.2 square feet for the blue and 2 feet for the red, and I only have 600 square feet. I can't go over. I could go under, but why not cover the whole roof? It looked pretty, right? But we don't have to. We could do less. So I could have a second equation. We could have a 1.2 B for blue plus a 2R for the red less than or equal to 600. So this is my area formula, okay? 1.2 square feet for the blue plus 2 square feet for the red less than or equal to 600. So we're going to go and buy some flowers and put them on our roof, okay? Now we got a cost problem. Even though she just graduated from college and she's going to make all this money, she hasn't earned it yet. So she only had $1,000 to spend, right? So they're both going to cost $250. So she goes to the store. Maybe it's Lowe's. I don't know. So she's going to have $250. So this is my cost of a cost equation. So $250 for the blue plus $250 for the red less than or equal to 1,000, okay? Now I want to graph this, because if I want to graph this, I need some kind of a feasible region. So when I graph these first two equations, I know I'm in quadrant 1, okay? If I want to graph equation 2, let's just call it equation 2, I'm going to need to solve for y. Well, in this case, y is the r, right? Yes, Austin.
For that last equation, the 2.5b plus 2.5r, wouldn't it just be less than 1,000? Because it says she can spend less than 1,000.
I'll go along with that. I will go along with what you said. Okay? I'm going to have to change the wording on that, Austin. I agree with you. Good. All right, so we have to solve for y. Our y value is actually the r. Do you agree with that? Because here's my red. So let's solve for r, okay? So in equation 2, I have a 1.2b plus a 2r less than or equal to 600. And let's solve. So let's bring over the 1.2. Okay? How do I do that? How do I bring over the 1.2? Austin says subtract. I agree. 2r less than or equal to a negative 1.2b plus 600. Okay? Divide by 2, right? Divide by 2. Divide by 2. I'll get r is less than or equal to, let's see, I'm going to do that. Probably negative 0.6, right? Negative 1.2 divided by 2. Yeah, negative 0.6b plus 300, right? How am I doing? Alright, I can graph that. I might need to change my scales. If I go by ones, I'm going to be in trouble, right? Go by ones, I'm going to be in trouble. So let's go by maybe, I don't know, let's go by 50s. I'll make that 100, 200, 300, 400, 500. And I'll have to do the same thing down here. 100, 200, 300, 400, 500. Okay? All right. Scoot this up a little bit so you can see better. Boy, if I had a fraction here to make it easy for me to graph. Luckily, we know math. We know how to do this. 0.6. 0.6. What's 0.6 as a fraction? 6/10, which reduces to? Hey, I like that. Let's change this to negative 3/5. It makes it better to graph, right? Negative 3/5. Okay. All right, I'm going to graph the first one. Let's see. Let's use, well, it's B for blue. Let's see if I have blue. Do I have blue in here somewhere? I'll use brown. Why not? Okay, so let's graph this one. Start at 300. 100, 200, 300, right? Start at 300. I'm going to go down 3 over 5. So down 1, 2, 3 over 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. Draw it in. All right. How am I doing? Okay. Shade below. Thumbs up so far? Let me see. Thumbs up. Sideways. Okay. Well, we need to graph the other equation. So let's graph equation 3. So I'll do equation 3 also. Austin, I agree with you, but I'm going to make an equal sign because I'm going to let her have exactly $1,000. If she needs a penny, I'm going to loan her a penny. Okay. So I'm going to go 2.5b plus 2.5r is less than or equal to 1,000. Okay. Now let's solve this one. Okay. How do I solve for r? Let's bring over the 2.5. So I'll have a 2.5r is less than or equal to 1,000 minus 2.5b. Divide by 2.5. Divide by 2.5. Divide by 2.5. R will be less than or equal to, let's see, what that's probably going to be 200. Let's see, 1,000 divided by 2.5 is 400 minus 1 over 1b, all right? And I'll do that one in orange. How am I doing? Am I going too fast or am I all right? Am I good? Thumbs up, everybody? Okay. All right. So to graph this one, I'm going to go up to 400, 100, 200, 300, 400. Slope of down 1 over 1, so I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over. Okay. And I shade, put that in, I shade below, right? And where they overlap is my feasible region, okay? So I'm going to darken that in green where they all overlap, okay? All right, so what we found, what is this? What's our feasible region? What is all of this? What is that? It's just the number, yeah, so it's two things. It's two things. Good job, Gage. This is where you can stay within budget and where you'll be able to cover your roof. All right? Now, there's a minimum. Okay, everybody look. All eyes up here. I mean, this point right here, see where my pencil is? That point right here, which is 50-50, I could afford that. It won't cover my roof, right? Right here, 0-0, I could afford that, right? It's not going to cover my roof, but it's part of my region. Right here, I can afford that, but it won't cover my roof. Now, out here, well, I can't afford that and it won't cover my roof, right? Right here, I can afford it, but it won't cover my roof. Right in here, I can't afford it, but it will cover my roof, right? So the only ones that work that will do both is in the green, right? Now, what's the best option? What do you think? What's the best option? Well, let's look at our corners, because your corners are going to give your max or mins. Real easy question. For our corners, you with me? Corners. Where's our minimum? Super easy question. Where's our minimum? You guys agree? If you plant no flowers, it doesn't cost you any money, but nothing gets covered. Kind of a boring roof, huh? But our corners then are going to be our points. Let's see what our corners are. My corner points. All right. Looks like I got a 0, 300. Looks like I have 100, 200. I got a 250, comma 150, right? Looks like I have a 400, 0. Okay, those are my corner points. What do they represent? How many what?
How many of each color of plants?
Nice. It is. So we can either plant 0 blues and all reds. If you like red, maybe that's what you want to do, right? Maybe plant 250, 150, 250 blues and 150 red. Or maybe plant all blue and no red. But there's an objective. What's your objective? What's your objective? I should just turn that down and off, right? Yeah. Hold on, let me turn this off. So what's our objective? Well, let's read on. Because you asked, what's the objective function? So Jillian wants to maximize her amount of CO2. Okay, she's worried about the environment, right? So she did a little research, and she knows that the blue will absorb 1.4 pounds per year of CO2, and the raspberry will do 2.1 pounds per year. So here's my creative function. We use P, and we'll go a 1.4 blue plus a 2.1 red, okay? Now, she's going to go out and buy some flowers. So if she buys the first corner point at 0, 300, let's go P of 0, 300, which represents 0 blue, 300 red. Let's find out how much carbon it's going to absorb. So we'll take and go 1.4 times 0 plus 2.1 times 300. So what did I do? I took my objective function. I looked at all of my corners, and I said, okay, well, let's go to the store. 0, 300 represents 300 blue. I'm sorry, 0 blue, 300 red, and let's just figure it out. So I'm going to use my calculator because it's always better to use my calculator. So I'm going to go 2.1 times 300, and I get 630. 630 pounds of carbon. 630 pounds of carbon, okay? So let's try the other corner point. P of 250, comma 150, right? So we plug in the corner point into our objective function. You guys know where I'm going? Take your corners and plug it in. So go 1.4 times 250 plus 2.1 times 150 and figure out that. Again, I'm just going to use my calculator to do that. All right, let's see what my calculator gets, okay? Let's speed this way up. 1.4 times 250 plus 2.1 times 150. 665. Hey, this one's better. Okay. In the last corner, we'll plug in 400, comma 0. 1.4 times 400 plus 2.1 times 0. And I get 560 pounds of carbon. So the question is, what should she buy? Which combination should she buy? The middle one. So she's going to go to the store now and she's going to buy. So I've got to answer this. I got to answer. We got to answer the question. We're going to buy 250 blue and 150 red to absorb 665 pounds of carbon. Okay? I'm going to back up. Daniel, I'm going to back up real quick. So here's what we need to do. We need to come up with some equations, right? We shade. We get a region, right? Then the big key to the region is you need your corner points. You've got to get your corner points. Because your corner points are what you're going to plug in. And then you're going to get some objective function that you plug your corners into. Then you just look for the best or possibly the least depending on the question, okay? Homework. Page 209. 2, 5, 15, 33, and 34, okay? All right. There you go. Actually, look at them. That's why they seem